This is the recording for the Unit 2 homework quiz. So question 1, just say, yes, I attend the on-campus class, or went to the collaborate sessions, worked out problems, watched the Mechanical Universe, and read through a chapter in the book, or chapters. This one here, so question 2, is you choose an exercise question from the chapters in the book on Newton's laws, in this case. You type it, you type in the answer, your answer to that, and then you also post it on a discussion board. It really looks more complicated than what it is. It's just the way I just described it a moment ago. Okay, question 3, look at the beginning of Unit 3 in Blackboard. Just as you clicked on this homework quiz towards the top, it says these are the objectives, and check all that apply, and if you look through them, they all make sense that this is what we're talking about. Alright, then question 4 is about the 3 Newton laws. Let me go back here for just a moment. So here you have law of inertia is the first one, then second one is sum of the forces equals mass times acceleration, and then the third one is the action-reaction, so 2 forces from 2 different objects that are acting on each other, and then they're explained here. Again, all these 3 here. So the next question then is restatements of each of those laws. So you will see that this is inertia, and then the next 3 are going to be force equals mass times acceleration, and that force, or the sum of the force and net force, is always acting on one object, and then the other 2 here are about 2 objects interacting with each other and exerting an equal and opposite force on each other. Alright, for this one here, you have to watch a certain video that I posted, and again, you're going to go back to the Unit 2 that's posted in Blackboard, and you find the link to those videos, and you watch them. You should be able to answer that question. And I want to say, top of my head, these are in the correct order. So something about billiards balls, and then cars, and then football players, and so on. And then there is a video, possibly the same video about, or maybe another one there, with the same link on YouTube, where you're going to watch that airplane taking off, ascending, flying, and then this continues on with the airplane. So question 6 here starts out to be in the correct order, I'm pretty sure, but do double check that. And I don't think these are scrambled on the right hand side. I think this is the order that you see them in, but anyway, I think this is ABC here. And then actually certain things will repeat. So it says right here, note that this reuses a previous statement. That's why as the airplane at cruising speed, you have this answer here with the 4 forces, as you can see in the video. And then as the airplane continues descending at constant velocity, it also has the same answer here, because both of them assume or state that it is a constant velocity. And then here you have a statement and another statement, and the last ones here should then be D, E, and F statements. But again, watch those videos and answer these homework questions. Okay, this is from the Worked Out Problems in Physics document, the 90-page document that I have posted, that I encourage you to print out and use throughout the entire semester. So you look at the problems that you find in there, and it says Chapter 4, Problem 2. I didn't put the page numbers in this particular one here on the homework quiz because page numbers over time could change. So here it says acceleration A equals 5. Well, acceleration is probably meters per second squared, so that's why I put that one here. It's really, I don't even see another possibility here, so that must be it. So then here again it says acceleration, acceleration. So it's kind of like almost cheating just looking at this word here, acceleration A equals 1, well, meters per second squared. But I still, of course, like you to look at these particular problems. That's what this homework quiz problem is about, that you actually are familiar with how to do the calculations. Force here, well, usually that would be in newtons. That's why I chose this one here. So this is probably going to be the same thing. Be a little bit careful here when you see the word force, because that could also be in pounds. You see, actually, I don't have pounds on here. It's all physics is metric anyway, but once in a while I do throw an American unit in here. Mass loss, you know, that would be in kilograms. Could be grams as well, but I'm pretty sure that the option here is kilograms. And so on. So look at all these here in the worked out problems. All right, let's see. General concept questions. So a rock is thrown upward and reaches maximum height. At that maximum height, the rock has a velocity of 0 and an acceleration of negative 9.8 meters per second squared, which is why the rock being at rest at that point but changing its state of rest will fall down again. Some people are inclined to say that, well, there is no acceleration. Well, that would mean, A, that gravity was turned off miraculously, and B, the rock would just hover up there, which of course it's not doing. Gravity is on all the time, so it's always trying to be accelerated at negative 9.8 meters per second squared, no matter where it is, on the top, on the way up, or on the way down. And of course it's not going to hover up there. It's going to fall down. Okay. Then here, this is the wrong statement that I posted right here. That's why, yeah, don't apply this one here. And then the driver of a car driving from left to right is hitting the brakes. And, oh yeah, left to right means imagine a picture or video, so driving left to right, hitting the brakes, that means the driver has an acceleration that points in the opposite direction of the motion, therefore slowing the car down. When a person accelerates upward in an elevator, the reading on the scale and so on would increase, and you have felt that kind of sensation. And again, I put the other wrong answers here. So no, it's not 0, and no, it doesn't decrease the way I worded it here. And then you would have to see, okay, here it changes. If the elevator was in free fall, the reading on the scale would be, well, everything is floating, so therefore the correct answer would be 0, because the scale wouldn't be able to read anything, and so on. So again, look at these concept questions. Question 9 then is from the extra book, How Everything Works. So read through that just by looking at the title where it says rockets. And apparently you don't have to read the whole section on that. So if it says something there about orbits, you don't have to read that, just about the rockets. And top of my head, well, rockets work on the action-reaction principle, so I checked Newton's third law. There should be something about liquid fuel on here, and then you would have to look for the others. Definitely only a certain number of them will apply. For example, Snell's law, that's optics. Fraunhofer diffraction, that's optics. Index of refraction, that's optics. Don't check those at all. All right, and then the last question, or second to the last, is the mechanical universe. I think it is second to the last question here. So here you have to watch a couple of them and check in the unit which videos those are. And then I give away here that invention, the one that starts, the quote that starts with invention is the first description. Therefore, I check number 1 here, and refined is the 5th, and that's why I call it number 5 here. And then you have to figure out where are the other 3. So you have to watch these videos to determine the correct order. And as I grade that here, I will notice if somebody just accidentally flipped a couple, and I will give people credit for it, or if somebody just is totally off, then I also notice, oh, you know, they didn't watch the videos. Which is why I say here, I recommend that you watch these videos only once, and then I explain that I will notice that who watched the video, even if they did make a small mistake. All right, last question on here. There is another video posted about this, and I believe all of these here apply, but go ahead, watch the video and see how that wall racing robot is doing. All right, and that was, oh, there's an extra, that was the extra question, yeah. And that is my recording on the Unit 2 homework quiz.